Hello, I'm John Cottrell from Matrix Science. Mascot Daemon is our automation client for Mascot Server. It allows you to process batches of raw files into peak lists and submit the searches to a Mascot server fully automatically. It's the part of Mascot that's only available if you have the software in-house. You can't use it to submit searches to the free public website. Also, Daemon is only available for Windows. This is because all of the mass spectrometry data systems are only available for Windows, and so this is where the raw files will always originate.
Mascot Daemon is our automation client. It's a part of the Mascot package that is only available when you have a Mascot server in-house. It's only available for Windows because all of the mass spectrometry data systems are Windows packages, so this is always the platform where the data files originate from. Links to install and update Daemon can be found on your local Mascot homepage so that anyone with access to the server can easily get a copy of Daemon. You should try and make sure that you have the same version of Mascot Server and Mascot Daemon installed. An older version of Daemon will probably work, but it won't support features in a later version of Mascot Server. When Mascot Daemon is first launched, this dialog will be displayed and you have to enter the URL of your local Mascot server to proceed. Note that you cannot enter the public website URL, it simply won't work. If Mascot security is enabled, you will also need to enter a valid username and password on the Authentication tab. Mascot security is not the same as web server security, or having to tunnel through a firewall or an authenticated proxy server. There are separate fields for each of these. Once Daemon has connected to the Mascot server, you will see a display like this. The user interface is a simple tabbed dialog box. Mascot Daemon has comprehensive, context-sensitive help. Just press F1. There is a tutorial to get you up to speed and detailed reference material. Let's look at the tabs in more detail. The Task Editor tab is used to define each task. A task defines what data will be searched and when the search will take place. A parameter set is selected that contains the search parameters. This determines how the data files will be searched. Here we have a very simple batch task. A single data file has been selected, a parameter set has been chosen, and the task will run the search as soon as we press run. The data files can be simple peak lists. In this case, we are using Mascot Distiller as a data import filter and the data file is a raw file. More about data import filters later. Note the checkbox at the bottom left. Merging a batch of files into a single search can be very useful. Mud pit fractions, for example. The parameter editor allows sets of search parameters to be defined and saved to disk so that they can be used over and over again by various tasks. The search parameters define how the data will be searched. As you can see, the fields are very similar to those in the web browser search form. The search title includes some tokens or variables that will be replaced when the task is run. Here, for example, task name in angle brackets will be replaced by the name of the task, and localhost will be replaced by the name of the computer on which Daemon is running. This will make it easy to identify where the searches came from when looking in the Mascot search log on the server. There are many such tokens, and you can find full details in the help file. Each search result is added to an Explorer-like tree on the Status tab. There is a minimum of summary information and a hyperlink to the full result report. Mascot Daemon isn't intended to be an interface to browse Mascot results, it's just a tool to automate search submission and keep track of the results. Data files within a particular task are run serially, but multiple tasks can be set running at the same time. This means that several data files can be processed and searched at the same time. Going back to the Task Editor tab, for some file formats, we have data import filters. These allow Daemon to generate peak lists directly from the binary files created by the Mascot data system. Next to the drop-down list, you have a button to view the options for the selected data import filter. For Mascot Distiller, you need to have a license for the Daemon toolbox. If present on the Daemon PC, Mascot Distiller will be added to the list of import filters automatically. All other data import filters must be configured on the Data Import Filters tab in Preferences. Install the package, browse to the executable, and save. A number of data import filters are pre-configured, and their options are described in the Mascot Daemon help. Just press F1. Thermo Extract MSN is a utility that creates DTA peak lists from Thermo Excalibur raw files. Mascot Daemon calls the utility using the parameters specified in this dialog, then merges the DTA files into a single MGF file. Extract MSN can be downloaded from the Thermo website, but Thermo is no longer developing or supporting it, so it cannot be used with their latest instruments, such as the QX-Active. The AB-SciX MS Data Converter supports both WIF files and TOF data stored in an Oracle database. Output can be an MGF peak list or an MZML file, which contains a more complete representation of the data. For rapid peak picking, the converter exports the centroids determined by the instrument software during acquisition. For WIF files, there is also an option to use the peak picking algorithm from Protein Pilot, which gives particularly good results on triple TOF data. Proteo Wizard MS Convert is a command line tool for converting between various file formats. It has a large number of options. Note that the input file format is not specified. MS Convert auto-detects the format. The most powerful data import filter is Mascot Distiller because it can import all of the major raw file formats. The dialog is relatively simple because the peak picking options are all contained in the selected processing options file. The idea is that you adjust the processing options by working interactively with a typical data file in Mascot Distiller Workstation. You then save these options to a file and simply select it here. You can ask Daemon to save a project file containing the peak lists and the Mascot search results. If you have search and quantitation toolboxes, you can also batch automate quantitation. We'll be discussing quantitation in detail in a later presentation. If Distiller is used for peak picking, once the search is completed, you get a hyperlink displayed which allows you to open the project in Mascot Distiller. Simply click once on the link and Shazam! The project opens in Distiller Workstation. Peak lists created by Daemon are always saved to disk. This is the default path, which can be changed in Preferences. When you delete a task, any peak lists associated with that task are also deleted. If you have used Mascot Distiller as an import filter, then the Distiller project file is also deleted. The raw files are never deleted. You may also find Distiller project files, log files, and result exports in the same cache folder. Let's talk in more detail about tasks. Mascot Daemon supports 3 kinds of task. A batch task allows you to search one or more specified files immediately or at a defined date or time. A real-time monitor task is the key to real automation. You define a task using the file path for the data file, but including wildcards. Any file that matches this path is automatically picked up and searched. A follow-up task is where the data files are passed to it by another task. This is very powerful because it allows searches to be chained together to implement quite complex workflows. For example, a batch of data files might be screened against a contaminants database containing entries for keratins, BSA, and trypsin, etc. Those spectra in the files which fail to find a match can then be automatically searched against, say, a non-redundant protein database. Spectra which are still unmatched can then be searched against, say, an EST database, etc., etc. When you select Real-Time Monitor in the schedule frame, the Task Editor tab looks like this. Here, we are looking in the specified directory and all its subdirectories for any file with the extension WIF. Note that the final part of the path says file or folder name. This is because some raw files are actually folders, not files. If Include Subfolders is checked, then Daemon will search down through all subdirectories of the root folder. If New Files Only is checked, then any files that exist when the task is started will be ignored. A common mistake when using Real-Time Monitor as a batch task is to have this checked and then wonder why nothing is happening. Follow-up tasks are a little bit more difficult to explain. Any task can pass data to a follow-up task to be searched again in a different way. Only follow-up tasks can receive data from other tasks in this way. Let's illustrate with an example. Imagine we want to search our MSMS data files against the mouse proteome in a first-pass search. We then want to search all spectra that fail to get a significant match against a database of mouse EST sequences. We must start at the end of the chain and define the EST search as a follow-up task. We choose follow-up in the schedule frame, and we choose a parameter set created earlier in the parameter editor that contains the required search parameters. We press Run, and we see our follow-up task is now running. Although the task is running, nothing will happen until we feed some data into it. We go back to the task editor and create a simple batch task. There is one data file, and the search parameters are a different set in which the database is a uniprot mouse complete proteome plus a second database of contaminant sequences. Before pressing Run, we have to link this task to the follow-up task. We need to specify a condition for passing the data to the follow-up task, which can be score-based or probability-based. For this example, we will use the default significance threshold of 5%. If the score for a peptide match in the first search is below the 5% significance threshold, then the spectrum will be passed to the follow-up task created earlier. Note that you also have the option to repeat the search at intervals, maybe to see whether a better match can be found in some future update to the sequence database. The task is now configured, and we can press Run. Sometime later, the status tab looks like this. The results for the first search appear under task 11. Those spectra that failed to obtain a significant match were passed to the follow-up task, task 10. This is where the result for this search appears once the search is completed. So to summarize, one follow-up task can pass data to another follow-up task, creating a chain of tasks to implement a complex workflow. Thresholding applies to individual spectra. If there are 1,000 spectra and 100 get a good match, we take the 900 that didn't get a match and pass them to the follow-up task. You can think of a chain of tasks as a series of finer and finer sieves. Remember that when you define the chain, you have to start at the end of the chain with the last task and work forwards to the beginning of the chain. Having created a follow-up task or a chain of follow-up tasks, multiple batch or real-time monitor tasks can feed into this chain. It just sits there waiting for data files. Note that any result node can also be dragged and dropped onto a follow-up task node to repeat the search using a different parameter set. We'll very briefly touch on a few other features of Daemon. The Task Editor tab includes a button labeled External Processes. A Mascot Daemon task can execute external processes at one or more of the following time points: at the start of a task, before submitting each search in a task, after completion of each successful search in a task, and at the end of the task. An external process is a one-line command. This could execute a Windows program directly, or it could be a batch file or a script to perform some more complex procedure. You can pass arguments to the commands by including tokens such as task name. The help file contains a list of all the available tokens. It also gives examples of how to use external processes, such as this script to build an HTML page in real time that contains hyperlinks to the search results. Mascot Daemon is divided into two components: a graphical user interface, or GUI, and an engine. We've been looking at the GUI, which runs on the desktop and is used to configure Daemon, edit tasks, view search results, etc. The engine is responsible for executing these tasks in the background, whether the GUI is running or not. If something should go horribly wrong, you need to stop and start the engine to clear the problem. Exit Daemon on the desktop, then locate the Daemon engine icon in the system tray. Right-click it and choose Exit. Running the engine in the system tray is the preferred arrangement in all cases, except if you want to run multiple instances of Daemon in separate remote desktop sessions on the same PC. Doing this requires the engine to be installed as a Windows service. You'll find full instructions in the help. Under the hood, Mascot Daemon stores information in a relational database. The installation default is to use an embedded database engine called VistaDB. This is the recommended choice unless you wish to share a single task database between multiple instances of Daemon running on different PCs, which requires a higher performance database engine. In such cases, you can choose from Microsoft SQL Server, MySQL, Oracle, and PostgreSQL. These are configured in the ODBC Connection tab of Daemon Preferences. When multiple instances of Daemon share the same task database, each task is owned by the instance that created it. You can only pause, resume, cancel, or delete your own tasks. However, any instance can clone any task and can transfer data files to any follow-up task, either by dragging and dropping the result node or by specifying the task in a follow-up criterion.